Hi, I'm Shinhe from Cornell. Today I will introduce our tool Valg, a fast reinforcement learning-based runtime verification tool for Java. Runtime verification has overhead, and one major reason is that more than 99.9% of monitors are redundant. They check the same traces as the other 0.1% check. So, we recently proposed a novel reinforcement learning-based approach to selectively create monitors while preserving violations. Our tool, Valg, is an implementation of that approach. Mainly, it improves our previous prototype with 6 new features. We will introduce some of the key features in this demo video. For the complete details, please refer to our paper. First, let me explain how to install Valg agents. Users can easily enable Valg features with minimal effort. This command will build JavaMob, the state-of-the-art RV tool without storing traces. And this command will build TraceMob, another state-of-the-art with storing traces. To enable Valg features, all that users need to do is to add Valg flag. For example, this command will build JavaMob agent with Valg features enabled. As you can see, all the specs are being processed with Valg features enabled. And finally, the agent is created. To run our tool for Maven project, users simply need to add plugin to pom.xml. And run Maven test. And as you can see, violations are being reported. For non-Maven project, users can pass -java agent flag when running the program. Now we will introduce per-spec hyperparameter feature. Our prototype supports the same hyperparameter values for all specs. Valg improves this by enabling different hyperparameter values for specific specs. Also, users can even disable RL agents for specific specs. For example, this command will build JavaMob agent with these hyperparameter values only for iterator has next spec, and RL agents disabled for array-dec non-null spec. All other specs will be processed with the default values. As you can see, array-dec non-null spec is not being processed with Valg features enabled. Next, we introduce trajectory saving, which is a sequence of RL agents' decision-making steps. All that users need to do is to add trajectory flag when building the agent. This command will build JavaMob agent with Valg features enabled, including the trajectory saving feature. And if you run Maven test as before, Valg additionally creates this trajectories file. And if we open this file, we can see the sequence of decision-making steps that RL agents went through. Lastly, we introduce offline hyperparameter tuning using trajectories. We provide an automated script which finds optimal hyperparameter values for a spec. All that users need to do is to pass the trajectory file, the target spec name, and the number of trials. For our demo, we tune for iterator has next spec with 30 trials. And we can observe the internal tuning process. And as a result, the optimal hyperparameter values are printed out. This is the end of our presentation, and our source code is publicly available. So if you are interested, please check out the GitHub repo here. Thank you.